I'm going to get started here with, basically I'm going to talk about a proposed internet draft on a protocol that I call RID, or Real-Time Internetwork Defense. And this is a method of integrating all the various single trace mechanisms used on a network in order to be able to communicate across network boundaries. And so it seeks to use existing standards and all of the various trace mechanisms that I've been able to find out there, and just is the communication mechanism between providers. Some of the larger issues are not technical, and so the draft touches on what some of those are and has some suggestions, but I'm hoping for feedback on both the technical and the social issues that many of you would be much more familiar with being in this on a daily basis than I might be. And then finally I'll talk about a small-scale implementation using email for transport, and the protocol is actually a TCP-based one. Email was used just for simplicity, for testing's sake, based on some suggestions from some people at ISPs. Okay, so some of the goals of RID is to be a real-time method to mitigate the effects of DOS and DDoS attacks by providing a way to trace across network boundaries. And this would also work for security incidents if there's a spoof source. Some of the goals were also to respect network boundaries, in that many of these trace mechanisms require you to be configuring equipment across your network, and so when you reach the border of your network in a trace, how do you get the next provider to do that? Well, RID just sends a request providing all the information needed to the next upstream provider and asks them, can you continue this trace? And based on information given and the status of the network, they can make that decision. And as I mentioned, it's meant to integrate the trace mechanisms that are available as well as any new and developing ones and detection methods as well. So it's not meant to solve those problems, it's meant to help integrate those together. Now here's just a quick example. So you have a target at your client, the pink network, and they detect they're under an attack. So in this instance, they figure out what types of traffic they're seeing, they get a sample of that on their network, and they send a RID request to their upstream ISP. And this is I include this at the client level because that would be a way for you to pay for this type of a system. So if you offer this as a service to your clients, then that may be some motivation for you to actually deploy something like this. This revenue is important. So the client sends this to their ISP takes a look at it and says, okay, this is reasonable or it's not reasonable. And if they decide to go ahead with the trace request, they'll send a message, a RID message back to their client and say, yes, we're going to go ahead with this trace, or no, we're not. And once they say that they will, then their individual trace mechanism used across their network would be utilized to either find the source of the attack or the border network. And in the first example I'll go through, it would be the blue network. So once that's identified, they then send a trace request to the blue network and say, hey, I'm seeing this traffic, it's coming from your network. Could you please continue this trace? And the blue network makes their decision, yes, no, and sends that response back to the pink network. And in this case, they're going to say yes. Makes my example a little bit better. And then they determine, after performing their single trace, that they have the source of the attack on their network. And in order to address some privacy concerns, the blue network may have an SLA agreement with their clients that says, well, okay, we will provide the information back to the originator of this request saying that, yes, we found the source and we did something about it, this is what we did. It may even be that you contacted the client, or you may have something automated that would let you automatically filter out the traffic. But you have the ability to either provide or not provide the contact information of the person attacking your system. Now, in a more complicated example, you have an intermediate network. And since this is going to be based on peer relationships, you're going to have bilateral trust relationships established through all of the upstream ISPs. So all of the messages, let's say in the case where it goes from the client under attack to the pink network, to the green network, to the blue, and then the source, all of those RID messages would have to pass through each of those systems because that's how the trust relationships are established. And so that might be something you would work out in peering agreements with the providers that you peer with. So with the trace mechanism, this is aimed at single network trace systems across your network. Examples of that would be things that were net flow or network flow analysis based or hash-based IP traceback. And RID would handle the case where you're doing that dynamically, where you receive this request and then you would iteratively look for that traffic if it's still on your network, or if you have a stored method such as the hash-based IP traceback, and hopefully you still have that time in which the attack occurred stored on your system. It wouldn't work, but might complement something like the ICMP traceback, which is probabilistic and more of an end-to-end solution, where you would, the end-to-end solution would be where you would be gathering all the path information. Some extensions I think that would be useful, and I should talk to Steve Sullivan about this, would be for a pushback. In some cases, you may not get all the way to the source to be able to stop the traffic, and you may want to be able to mitigate as close to the source as possible by doing some rate limiting, and so that I think would be a useful purpose for this as well. Now, the parameters for the trace approaches, so this is what you would need in your trace request going out, is the superset of what I found to be needed by all the various trace mechanisms that I could find, which would be the time in which the attack occurred, the non-changing fields of the IP header, and then the first 8 bytes of the packet payload. If there are others, please let me know. Your feedback and collaboration would be greatly appreciated. Now, for the inter-network communications, you would be setting up a system that you would be communicating with your peer, and this might be a network management system, so there's going to be a lot of security implications here. You're going to want to protect this resource, and so within the draft there are some provisions about the security of the systems, as well as a method for authentication and encryption of the sessions. Ideally, it would be great to use an out-of-band connection. However, that might not be realistic, so authentication with an encrypted channel would help to solve that. And let's see, so these relationships might be established through peering agreements, and at that time you might work out any legal issues or ways to determine between your various providers how you might interpret the severity of a request that you receive, so that you're not only basing on whether or not you'll continue the trace on the actual type of attack that you see, but a confidence rating that may correlate back to something that's pre-established between you and your peers. And with your clients, you may set this up with their SLA agreements. And let's see. So with the notification and attack mitigation, that comes into play with the last message, the source was found, and what actions might be taken as a result of that. If you're going to block at the source or filter out the type of traffic, or just call the client. So those are all options, and that would need to be integrated into your network or done manually depending on how you would prefer to do that. And another potential problem of this system could be that if there are multiple traces in a distributed denial of service attack, you may wind up causing a denial of service against yourself. So bandwidth dedicated to actually receive these requests is important. And then also looking at your resources on your network to determine how many traces can I support at a single time, and queuing those up to a reasonable number, and only doing, based on your network resources, as well as keeping track of what you've already done. So there's a table, an incident table that you would maintain of all of your recent trace attempts, so that you could say, no, I've already done this. That would prevent a loop and multiple traces if, let's say, you have a client that's multi-homed, or a system that's broken, or somebody at one of these trusted ISPs down the line has some malicious employees. So those are important to note as well. And there's also a human interaction factor. So if there, besides just the approved and denied, there's also a pending status. So if your automated response doesn't automatically say, oh yes, I'm going to continue this trace, or no, you have the option for the system to sit there and wait until somebody can make that decision on behalf of the system. So getting to the email-based test system. Well, RID is just a messaging system. It's pretty simple, so the test worked. And some of the lessons that I learned out of this were basically that the algorithm is much further along now, and it's based on the current draft version, so I'll have to make changes as it evolves and as your suggestions come in. Besides that, some of the tougher integration pieces are with interacting with all the various single trace systems. So your individual trace system is going to receive a RID message and say, I'd like to perform this trace, and has to interact with your system to be able to perform that trace, and then wait for the response to see what do you do next. Do you have a source found, or are you going to generate yet another request, and you're going to enter this into your state table to make sure you're not doing multiple requests? And also it will be in your incident state table to keep track of the responses that you'll be receiving over time from the upstream peers that this may traverse until you get the message saying source found or trace request denied. And so in my test, I used the resources that I had, and I don't have a large network to play with a full-blown trace mechanism. So I used libpcap on one server that was capturing packet headers, and used NetFlow with NetFlow tools on another system, and basically implemented the trace mechanisms where one would receive the email, parse off the header information, process the request, and take subsequent actions, and then send it to the other network, and then respond appropriately with either the allowed or denied messages, and then the source found message. So some of the current issues, I guess the technical ones are the easier ones to deal with. The social ones will be the more complicated. And this is in the Internet Draft Standard process. So one of the major issues is that I'm going to need more feedback. I do have some people interested in looking to implement this already. However, I think more review is necessary in order to figure out exactly what is needed to help solve this problem, and more collaboration from people doing these types of approaches. So I think that's the major issue, and then working out to figure if the social issues are too big of a problem, or if there are ways that those can be worked through. And so in summary, RID is trying to use the existing and developing technologies for single trace and integrate those for a faster trace across multiple network boundaries. So you're not making phone calls. It's quick, automated. You get the actual message, hopefully in a dedicated fashion, so that it's brought to the attention of the correct people very quickly. And then to look further into it, the draft is at the URL listed, or if you search on my last name, it would be in the individual draft submissions. And my email address is Moriarty, MORIARTY, @ll.mit.edu, which is also listed on the draft. And I have a mailing list set up for discussion. So if you send me an email, I can add you to that discussion list, and hopefully we'll get some useful input out of this. Thank you.
When you say, Randy Bush, when you say social issues, you really mean things like the legal issues of disclosing packet content to another legal entity without authorization, et cetera, yes?
That would be one, yes, and also coordinating, the social issues might also include coordinating the communication between you and all of your peers. And that might be done through peering agreements is the one thing that I could think of.
Yeah, we kind of know how to do that, but the minute it gets to one of your slides was telling who the user was. That's the lawyers.
Right, and so as a result of feedback that I've gotten, I left out, or I added the part where you can leave out who the source was from. And another stipulation, too, is that, let's say you're an ISP, off of only one ISP, there is an option to have that upstream ISP respond on your behalf with the action taken at the end. So that would help to alleviate those privacy concerns as well. And as far as integrity of the source of the trace, there's a digital signature included on the packet from the originator of the request. And so that should help to alleviate those issues.
Yeah, John Larson. I'm curious about response time in this kind of thing. We've already seen attacks that have over 140,000 source machines and aggregate OC192. With these kind of scale attacks, you can envision dynamically shifting attacks. With a large army, you can basically perhaps keep somebody down for a long time, depending on the response time of the system, just by shifting the attack to different sets of your army.
Mm-hmm.
So,
okay.
This is indeed a DDoS hole in itself.
Right. The timing issue, I think, would be more on the single network trace mechanisms implemented across your network. So this is just to help speed up the communication between providers. So it's open and flexible to use whatever is developed. So as technology evolves and that becomes faster, hopefully that issue will be addressed. But this is a very simple communication mechanism. I hope that helps a little bit to answer your question.
Thank you, Kathleen.
Thank you.